I am Ankit. I handle tech things at SigNoz. That's an interesting open source project that we're building. Today's talk is mostly around why we chose an distributed columnar database to build our open source tool on. Right. So something about me. So right now I'm building SigNoz. Started a couple of startups earlier, 5-6 years earlier. Then joined a startup in Bangalore, worked for 5-6 months. Job was not my piece of sit then. Handled a team of 8 to 10 engineers, distributed systems, microservices. I'm always interested to understand how deep technical challenges could be solved using tech things and all. Right? So that's a brief about me. And apart from work, I love going on trips, Himalayan treks. I have done a couple, like I can talk about that too. Right? But yeah, something more about SigNoz. So we launched in last year, Feb. We are part of Y Combinator. Right now we have 10,000 plus GitHub stars, 1,600 plus community members. We have a lot of issues and communications between the users and us happening. So it's like, you will love it when you join the Slack community. And we have more than 80 contributors across multiple repos. So how many of you folks have worked with monitoring traces or logs? Quite a handful, and that is what I was expecting, right? So, as you know now, like observability has 3 pillars, metrics, traces, and logs. Metrics is mostly about aggregates. Logs is diving deeper into individual execution lines that you would like to understand about the system, what is going right and wrong, and try to debug things out when the metrics do not seem to be very green and good. Right? And tracing is relatively a new concept, and it was like famous like 7-8 years from now, but it started picking up after the architecture of microservices came in. Service A calls service B calls service C calls service D, and then a database calls, and it gives back to the user. So, and each of these services are running on multiple instances and multiple nodes. So you have to figure out if something went wrong, either on one of the instances of service or database took a lot of time, longer time, you'd like to know what happened and where. Right? So that was the root, like the birth of distributed tracing. You trace one request down to the end and how much latency, like it basically gives you a causal graph. Right? So when I was building an observability tool, my first primary concern was I want to build all 3 into one, like too many tools for metrics, each for traces and logs. So I wanted to combine all 3 signals into one, and I wanted to understand how would these intercorrelate and what more value we can give to the users, right? So when I was designing this system, I had 3 most important considerations in mind, apart from all 3 being into one. Right? So one was like, I wanted to have good performance over analytical queries. With analytical queries, we want to do some sorts of aggregates, sums, averages, and percentiles. So these sort of things we want to play around with, rather than fetching the raw event in like, show me a list of 10 raw events. Right? So these are not aggregate queries. And there are aggregate queries that like, give me sum of CPU utilization across this zone, across this set of instances and all. Right? So the other thing that is very important is this tool or system must have the capacity to ingest huge rate of ingestion. The events, the telemetry system can generate 10 times or 20 times the amount of ingestion rate that your whole business is handling together, right? So because each request has multiple events that are emitted, like it can be 40, 50, or thousands, or even 10,000s of spans, right? The next important thing was to have a sort of tiered storage that can be utilized to reduce the cost of the data that is not frequently queried. Right? So with these things in mind, like there can be a couple of databases that we can choose from. We chose columnar database. The columnar database means all the rows or all the values, all the records of one column are stored sequentially in the disk. So when we do disk reads, it's much faster. If we have to query, smaller number of columns as compared to relational database where records are written row by row by row, right? So when you want to filter less number of columns and have to aggregate on millions of rows, then distributed columnar database is a very good choice. So we went ahead with ClickHouse, but despite or before that, we had a couple of options before choosing a database. It was ClickHouse, Peanut, or Druid. When the project started, we had a trial with Druid. Like Druid was much more operationally complex and difficult to manage. And the minimum amount of resources it took was a bit larger than what we wanted to have or what we wanted our end users or community users to observe. Right? So we went ahead with ClickHouse, and it is actually blazing fast at doing ingestion and at querying, and that too occupying minimum set of resources. Right? And also it has hot and cold storage, like you want to keep 1 month data, after 1 month you want to send it to S3 or even less the tiered storage of S3. So it is all possible there. So today, I'm going to talk about something that is not published out there in the blogs. I will talk about the performance of SigNoz along with, like, it has underlying OpenTelemetry collector and the database together. Right? So we'll have it out in a couple of weeks, but here are the glimpses that you can see. By the way, how many of you have been Elastic users? Right? Not that many. So you will love this PPT and you would like to rethink your design system there and what is happening when and where. So I am not sure if these fields are very visible to you, but the point is, this is the rough schema that we use to store our distributed tracing data. The important point is, we extracted out the most frequently columns that we used from the attributes tags or labels into a fixed column. That would give us much faster aggregation capabilities when we are trying to query them. Apart from that, ClickHouse has very fantastic set of compression techniques like LZ4, Gorilla, and ZSTD compression. So these are very good or performant when it comes to compressing the data. Right. So that is the kind of model that we are working out with. A few examples from the GitHub repo. When I was going through Jaeger repositories, there were also discussions around which database to choose, Elastic versus ClickHouse versus Cassandra. Like Cassandra is a key value store, does not have capabilities to do great aggregations. But Elastic does have some sort of aggregation capabilities. It was built not for aggregation, but for indexing and frequent querying of data, and that should be blazing fast. And Elastic is actually fast there. Right. So a few of the comments like says that it is better in disk IO, has very good data compression, ingested 250,000 spans per second, and like resource requirements by ClickHouse is, you will feel it is like 5 to 10 times lesser than what you need in Elastic. Right? And in our distributed setup, we tried running, we tried ingesting around 500,000 events per second into a distributed setup of SigNoz along with ClickHouse, and it was taking around 120 CPUs to make it happen, and the queries were also blazing fast there. So when we query data, we are talking about hundreds of millions of rows and not just like thousands or hundred thousands of rows. Some of the key capabilities that this kind of a schema enables, I would not like you to go to the green part of things, rather I would like just get an understanding of what is we are trying to do. If you try to group by or filter or aggregate by some field, it becomes very much more performant. Right? So aggregating by a tag attribute like customer ID, if this customer ID is facing some errors or this channel type is facing some errors, that sort of things would be very much faster in ClickHouse. And with the span data, there is also a kind of data attached that is called events. That events is highly underutilized today. And all the other vendors or open source projects rarely give you the ability to query those sorts of events. The event has a separate data model, it has a name, it has a set of attribute maps, okay, and it has a timestamp. Using a native ClickHouse queries, you can do aggregates on the values, on the counts of those events also. You can filter by them, you can do counts on them, right? So traditionally, what we have been hearing about is we are getting less value out of traces is because of high cost of storage and low aggregation capabilities and low value that we can generate, because we are not harnessing the data, rich data that it has underneath. So we'll go with some sort of metrics performance benchmark, like we have a setup where C6i 8x large machines with 32 CPUs and 5 TB of persistent disk. There is a benchmark tool or GitHub repo published by Victoria Metrics, which is called Prometheus benchmark. It basically tries to simulate 2,500 targets that are generating data and scrape it with different scrape intervals, and you can ingest into your system to figure out how it is working. So in total, we ran it for 10 hours. The total number of samples were around 9 billion. Number of time series that we stored was 9 million. And we had some sort of query performance there, right? So we just wanted to compare with Prometheus, like how it went. Victoria Vectors is a whole different story altogether. Apart from being distributed setup, it can be moved to multi-tenancy. It can be a long-term storage for different tenants and distributed horizontally scaled. So the other thing apart, these are raw queries that we ran. The most common type of queries that we usually do with Prometheus is sum by an instance or some common field and have some filters in the query. So that kind of query, the first query type was roughly 40% the time. It took almost 40% time that Prometheus took, and it ran for around 350 million samples. Okay. The second type of metric is a rate metric, which with some sort of filters without any aggregation. And this has slower performance than ClickHouse. Right? Prometheus is much faster there because it is a TSDB designed indexing. There is an inverted index that is present that helps you find out the exact time series that you want to figure it out. Right? And as we discussed, fetching raw data for ClickHouse is not that blazing fast. It is not meant for that. But for aggregation sort of capabilities after filtering, it is blazing fast. So it's the same set of performance we see when we try to do queries on top of ClickHouse. Right? So fetching raw data was slower, 2 times to 3 times slower, but it was double the performance when it turned out to be running aggregates on queries. The next is the storage performance. The storage performance is slightly slower, like it's almost comparable. If we change indexes, we can get even better, more compression. We were around like 20%. We took more storage needs than Prometheus. We were roughly around 20%. Now we move to logs, like we have traces in place. Traces was the first version of SigNoz it was released with. Then we had metrics. Now we have logs, released last 3 months back. So logs performance benchmark was radically different. We have also open sourced the setup under SigNoz/logs benchmark. That was a piece of state that was missing across the open source ecosystem. Very few of the companies used to benchmark the system and the capabilities, right? And we wanted to do that. So we have 3 VMs that were generating data all with 8 CPUs and 60 GB RAM. There was 1 VM deploying the stack of SigNoz, 16 CPUs. There were multiple flog generators. Flogs are basically engineering sort of lines. We added some dummy data to it, so to that we increased the number of bytes that we are ingesting, and the benchmark link, right? So each log size now is of more than 1.5 KB and around less than 2 KB, and the total amount of ingested log is around 500 GB. So this is like a typical log line that you would see where we tried it out with, and it has been open sourced. The dummy byte is used to increase the number of bytes that we store there in each log line. So it increased by almost around 1 KB in each. So roughly it moved it to 1.5 KB to 2 KB. This is the almost architecture that we use to ingest data into SigNoz. Multiple VMs, collecting data into OpenTelemetry using Flog, OpenTelemetry pushing data to hotel collector again, which is part of SigNoz, writing to ClickHouse. Right. So this is the rough infrastructure profile that we observed. We could ingest 500 GB of data in 2 hours. The ingestion rate was around 55,000 logs line per second or 75 Mbps, using roughly at a constant rate of 40 CPUs and 20% of memory. So this, as I said, is blazing fast ingestion. Comparing it with Elastic, right? So Elastic has other capabilities, but during ingestion we did the benchmark, and the same 500 GB of logs data was ingested in 5 hours at an average indexing rate of 20,000 log lines per second. And the CPU utilization, like first we observed like it is half the time to ingest the same amount of data. Next, the CPU utilization was almost double, memory utilization was almost triple, right? So that sort of observation, so almost ingestion is 5 times higher with the same sort of resources, you can see. Regarding storage, so we indexed everything that ELK did in SigNoz or in ClickHouse using different indexes. The storage comparison was roughly around like, we took around 207 GB and ELK was taking around 388 GB. The number of documents or the number of log lines that we stored was around 380 million log lines. Loki was good at ingestion, but Loki has different limitations when it comes to ingesting high cardinality data. Right? You basically cannot ingest high cardinality data into, because it works in a level of streams. The querying capabilities becomes very slower. There is no indexing for high cardinality data, and you have to retrieve all the records for that, and then do you sort of post-processing for that. So the query did not used to run like the queries or that I used to perform for logs did not used to run at Loki. So here's a glimpse what we read from the Uber's blog, engineering blog, when they moved from Elastic to ClickHouse. And this is a snippet from there. Like the right-hand architecture is what they used. They wanted to extract out that into 3 different arrays of integer, float, and string, and they want to query there. They observed, they wrote in the blog that their ingestion was 300,000 logs per second into one ClickHouse node. They did not mention the type of node, I don't remember. But the same node in ES was taking 10 times lower ingestion rate. And when they queried their users about the type of queries that they do, most of the queries their own internal team does on the observability data is around aggregation capabilities or analytical capabilities, right? Like terms, histograms, percentiles, and everything, right? So, and Elastic is not designed to support that. So all this helped Uber move from Elastic to ClickHouse, and they're doing that. Not just Uber, company Cloudflare you all must be aware of. They also moved from Elastic to ClickHouse for logs. What they observed was 8 times CPU and memory resource improvements. Like it took a lot less of CPU and memory. Like imagine running 200 CPUs versus running 30 CPUs, right? It's a lot of difference. The storage also increased by 10 times due to the compression capabilities of SigNoz. And they now did not have to sample the events to reduce the ingestion rate. So now they could send all the data into ClickHouse and run it. So the brief summary from there, ClickHouse seems to be a good fit because of the distributed nature of the database. Uber has tested ClickHouse. There can be, you may find blogs from eBay and all to like how they ingested metrics data, and I had a word with the observability engineer who built it there. So they all were very much bullish on ClickHouse. Next, the aggregation of span data can open a plethora of queries that you can write into your observability systems and generate insights from that data. Right. So, and obviously like less resource intensive to ingest the data. So at SigNoz, we tried to have all 3 pillars into one. We are now performance benchmarking. We have enabled powerful trace filtering and aggregation capabilities. We have out-of-box solutions like SaaS vendors, because that's the main problem of using OSS projects. The maintainers usually do not give out-of-box solutions, and it is a hassle for the users to set things up, set configs up, and migrate from older version to newer version. So we try to help our community in those sense, and we think that open source community is going to evolve more towards supporting user when it comes to migration and giving more user-friendly tools to the user. Those folks who have not heard about OpenTelemetry, it standardizes, it's an open source tool and it standardizes the data generation part, so, and the collector part, not the backend or any solution things, right? So it removes the vendor stickiness from your tool out. You can instrument all your applications with OpenTelemetry, and you can ingest or send data to any of the backend for analysis, right? Right, so this is the architecture of SigNoz right now, how it looks. So you have multiple applications, 1, 2, 3, even OpenTelemetry collector agents can be on your left-hand side. The applications send data to OTel, and OTel collector will send data to SigNoz, and SigNoz has OpenTelemetry collector that can receive the data. OpenTelemetry collector is horizontally scalable to ingest the load that you're sending. It will write to ClickHouse. ClickHouse has a tiered storage to send data to S3. We have written a query service on top of ClickHouse to expose some APIs to frontend that that the UI can utilize to plot beautiful dashboards and charts and aggregation capabilities. The query service also generates alerts that are compatible with Prometheus Alert Manager. So we have forked the Prometheus Alert Manager, built out some out-of-the-box capabilities, and the query service sends data there. So I was about to give you a quick demo, but I don't think the internet ability. But yeah, so that's all from me. Feel free to join our Slack community, discuss more about observability, OpenTelemetry. I would be happy to help you all out. That's all. Thank you.
So my question is mostly concerned towards logs. For log-intensive platforms or systems, where you get a large quantity of logs, or the size is very...
Sorry, I'm not able to get you. You're talking about docs, documentation?
Logs, yeah. In perspective of logs, for log-intensive platforms.
Okay, yeah.
Logs-intensive platforms.
Yeah.
Is ClickHouse the right fit? Because scalability, storage scalability becomes a problem statement in that case, right?
No, why do you
With
think
Elasticsearch, you can horizontally scale storage.
You can distribute ClickHouse setup to multiple hundreds of nodes.
Okay.
And you can use tiered storage and send it out to S3. That's not an issue. Like Uber and Cloudflare have used across hundreds of nodes.
Okay, so with ClickHouse also same kind of setup can be implemented?
Yes. We have not enabled it at SigNoz. It is going out to be like within a month or 2 weeks. We have tested it out, like the benchmarks that I published talked about ingesting 500,000 events per second. It is still under POC. We have completed that, but we'll be releasing it in coming weeks.
Okay, thank you.
Sure.
Thanks for the great talk and the insights. My question is regarding comparison with Splunk. So Elastic versus Splunk, I think Splunk has way more throughput and...
That's true. So Splunk, till now what I have heard from Reddit and blogs, Splunk is still a fantastic tool, but it's very costly. I wanted to do a performance benchmark, but the license of Splunk open source does not give you license to benchmark it against any tool. So that's why I couldn't go ahead.
Okay, thanks.
You spoke about OpenTelemetry metrics, right? On the same way, can we get the data out through PromQL or any standard query languages?
Yes, so mostly for metrics, PromQL has been very dominant in the market and is actually a very good style or way of querying your data. So for metrics data, we have enabled querying by PromQL, and it will internally convert or use the corresponding way to get the data from ClickHouse and display it using PromQL. Yeah, so supporting building dashboards using PromQL is possible.
Hi.
Hello.
I've used SigNoz in the past, so kudos to you for building out a open source observability. I like that. One question.
Yes.
So would the logs, so with recent addition, I've not used SigNoz for a while, probably half a year or something. So with, I think the recent addition of logs, right, can it be like a drop-in replacement for something like, let's say ELK or something? Not.
I am not able to follow you. Can you please repeat?
So would it be the current release, right, with logs? Would it be like a drop-in replacement? Can I use it like a drop-in replacement for like something like ELK or Elasticsearch, basically? Yeah.
Got it. So for log filtering and aggregation capabilities, it is. When we talk to users, we realize there is a couple of more features that users need when they want to use logs in production per se, right? So one of those things is setting alerts on logs, right? So what will the users do if they see some erroneous, like they should have some alerting technique, right? So till now we just have alerts on metrics, alerts on using any of the ClickWise queries on either of traces, metrics, or logs is coming out next week. There's another very important feature that is required for logs to be in production is that you want to generate metrics out of logs. So when I studied about this problem statement, it is important when you have to retain the metrics data for a much longer time and logs data for a shorter interval of time. So that it's then that you want to create metrics out of logs. And the second requirement during that time is you have logs ingestion at a very high rate, maybe tens or hundreds of thousands of log lines per second, but metrics is generally an aggregate that is stored to the aggregated something. So that's why fetching or plotting a chart from metrics is much more efficient than logs. And yes, we are working on it that too. We are PRDs in progress and happy to discuss more on this later. But yes, till the filtering, till the schema, everything seems good till now.